An altitude is drawn from the vertex of an isosceles triangle forming a right angle and two congruent triangles. As a result, the altitude cuts the base into two equal segments. The length of the altitude is 26 inches and the length of the base is 9 inches. Find the triangle's perimeter, round to the nearest tenth of an inch. All right, so if I were to look at a triangle, and I'm just going to draw a random one, let's say something like this right here. Now that could be a right triangle. I don't really care if it is or not. But if I were to look for the altitude of a triangle, it's the distance from one of the corners to the opposite side lengths like this. Now if it creates an altitude, it must also create a 90-degree angle between that line that I've drawn, which is the altitude, and then this opposite side length, which we would also call a base. Now it doesn't have to be there though. Sometimes they'll take that altitude and they'll be like, look at it, it's gonna be right here instead. Now again, is this a very good line? I don't know, but they'd have to create a 90-degree angle right there, and then you'd have a different base. Or if they were to change it and say, look at this one right here, and then maybe it makes a right angle right there. Okay, again, this is an altitude, and then this would become the new base. It depends on how the triangle is drawn. So that's how we define an altitude of a triangle. It's also known as the height of a triangle. If, for some reason, you already started with a right triangle like this one, the altitude would be given by either this length or this one of the two legs right there. If we can understand what an altitude is, then it will make sense of this isosceles triangle business. So an isosceles triangle is where we have a triangle that has two side lengths that are the same. Okay, so an isosceles triangle has two congruent side lengths. Congruent means they are exactly the same. Now, if I were to draw an isosceles triangle, and since my drawings suck, it may not look like one, but it would look something like this. Okay, so I have something like this. In fact, I'm gonna, not because it sucked, because all my drawings pretty much suck, but I'm gonna make it something like this one right here. Okay, that way it's kind of proportional. Now, how do I know this is an isosceles triangle? Well, it'd be hard to tell because my drawing sucked. But what I would notice is that if I put markings on this, then I force this to become an isosceles triangle no matter how bad my drawing sucks. So I've got these two side lengths that are exactly the same, and I know they're the same because my markings are the same for these. Do you have to put markings on these? No, as long as you understand what an isosceles triangle is. So we have this isosceles triangle. Here's what else it says. It says you got the isosceles triangle. From the vertex, you have an altitude drawn from the vertex of an isosceles triangle. We'll call this, a vertex is just one of the corners. But it says that the vertex is going to form a right angle and two congruent triangles. So that means that it would have to go from this vertex, not this one or this one. It has to go from this one. And so I get a vertex right here in this bottom corner, and then I'm going to have an altitude going straight through the middle of this triangle, forming a right angle here and a right angle here. I got two right angles, but it doesn't matter. Okay, so my blue line there is an altitude. I have the side lengths here that are the same because it's an isosceles triangle. It says the length of the altitude is 26 inches. Okay, so I can go in here. The blue line then has to be 26 inches right there. And this is the inches mark there, the double, I don't know, is that apostrophe? I don't care. So that's the length of my altitude, which we have marked already. The length of my altitude is 26 inches. What I see next is that we have the length of a base, which is 9 inches. Now the base should be created with the altitude, which makes the base this length right here. So that's going to be 9 inches right there. So you can see, well, maybe you can or can't see the right triangles. They're there. And I'm not talking about the whole isosceles triangle. What I'm talking about is the altitude. If I were to treat this as a cutting line, of course, hopefully yours are straighter than mine, but then you would cut this straight across. And then what you'd end up with is a right triangle. So let's see if we can show this. So I'd have something like this one, and then this, and then you'd have this. Oh man, that's not too bad for me. All right, so this right triangle, because the altitude created a right angle with the base. The problem is that the base was altogether 9 inches. But what we've done is we've gone through and cut this thing directly in half. And it didn't say that, but it did say that it cuts it into 2 equal segments. So that's in half. So I can't just use the 9 inches. I can't say, hey, look at this one, it's 9 inches right here. I cannot do that, although it's a common mistake. What we've got to do is take the original base length of 9 and cut it in half. So I'm going to divide it by 2. That's going to be 4.5 inches. So this length right here is 4.5 inches. And then the altitude, which I have in blue, it still is 26 inches. I guess I should have read the question. We're trying to find the triangle's perimeter. But all of this is going to be helpful in finding the perimeter. So once I find this length right here, which is the hypotenuse of this right triangle, then it will be the same as this length. And so I can take those two, add it to 9, and then that will be my perimeter. Okay, so we need the Pythagorean theorem here. So let's get it in there. There's my Pythagorean theorem for this half triangle, my half isosceles triangle. We don't know what the hypotenuse is, so we can't really square it, but we can take one of the legs, which I'm going to say the first one is going to be 4.5 there, and then my other leg, which is 26. So we got 4.5 squared plus 26 squared equals this hypotenuse as a square. So I'm going to need some calculator help, because I can't do any of this stuff in my head. Now, of course, I'm going to show this once again. I'm not going to do it. But if you wanted, you could take right now the square roots of both sides and then just type this whole thing into the calculator if you wanted to. I'm not going to do it. But in my calculator, 4.5 to the power of 2, this gave me 20.25. And then 26 to the power of 2 gave me 676. So of course, if I were to add those together, I should get the hypotenuse as a square as well. So let's go ahead and add those two together. We're looking to add these two. And when I do, I got 696.25. Now that's the hypotenuse as a square. We do not want the hypotenuse as a square. What we want is just a regular old-fashioned hypotenuse. So to get that length, I'm going to need to square root both sides here. All of it. So the square root in my calculator of 696.25, enter, and I get this number. And I guess I will round it. I will round it right now. So it said to round to the nearest tenth. I like to be a little conservative here and say, well, I'll just round to the nearest hundredth and then round the answer at the end. I don't think it's going to make a difference. So I'm going to round to the nearest tenth here, which means I look to the right to the 8, which is going to add 1 to the 3, making this hypotenuse actually 26.4. That was in inches. Okay, now that's the hypotenuse. This is not the answer. So we got to be careful on that. This is not the answer. It just tells you the length of this hypotenuse of the half triangle, the one we cut in half. But there's going to be 26.4 inches. So I'll write that in. 26.4 inches. Now that means that I can now go back to the original triangle over here and say, look, it's an isosceles triangle. We just found this length at 26.4 inches, which means that the other length, because it's isosceles, is also 26.4 inches. So what I have is the side lengths of the whole triangle. We got 26.4, 26.4, and 9. All I must do is take those values and add them together. So I'm going to do that here in the bottom corner. 26.4, that's a decimal, and then another 26.4, and then old 9er. And we're going to add these together in order to find the perimeter, which is what we do want. So I put this in the calculator. and have a number that's already rounded to the nearest tenth. I got 61.8. And yeah, we need to label this in the end because we know it's in inches. That is all. All right, a little bit of work there. And it takes a little bit of remembering that isosceles triangles, this is from 7th grade, isosceles triangles have 2 congruent side lengths. Or even altitude stuff and base stuff, that's all 7th grade stuff. But it's come back.